Penguins take thousands of naps every day. The bird's impressive ability to nod off may be an adaptation to an environment of constant interruptions. Penguins are champion power nappers. Over the course of a single day, they fall asleep thousands of times, each bout a few seconds long, a new study has found. Although animals have a wide range of sleeping styles, penguins easily take the record for fragmented sleeping. It's really unusual, said Paul-Antoine Librel, a neuroscientist at the Neuroscience Research Center of Lyon in France who helped make the discovery. This just highlights the fact that we don't know much about sleep, and all animals are not sleeping like the way we read in textbooks. The study was published on Thursday in the journal Science. The science of sleep got its start in the early 1900s when researchers used scalp electrodes to discover that people produce slow brain waves when dozing. They found similar wave patterns in mice, pigeons, and other captive animals. Over time, scientists discovered that pretty much every animal they studied spent some time each day unresponsive to their environment. Even jellyfish sleep despite their lack of a brain. But how animals sleep varies a lot. Brown bats remain asleep for 20 hours a day, whereas giraffes get by on less than 2 hours. Human brains shut down entirely when we sleep, while seals can shut down a single side. With the other still awake, they can continue swimming as they doze. As technological devices have become smaller and more powerful, researchers have discovered that sleep patterns documented in animals in captivity are significantly different from those observed in the wild. In zoos, for example, sloths will sleep for almost 16 hours a day. But in a Panamanian rainforest, scientists observed the animals sleeping for less than 10. In 2019, Dr. Librel and his colleagues tracked sleeping animals in an even more remote environment, King George Island, just 70 miles north of Antarctica. Won Young Lee, a researcher with the Korea Polar Research Institute, invited the group to accompany him to the island, where thousands of breeding pairs of chinstrap penguins gather in nesting colonies to raise their young. In December 2019, the researchers outfitted the penguins with electrodes and other sensors that recorded their activity for up to 11 days. The birds split their time between swimming in the ocean and staying at the nests to keep their eggs and chicks warm. Between each trip to sea, which took around 9 hours, the penguins spent 22 hours on average, taking turns caring for their young. While in the ocean, the birds barely slept, spending just 3% of their time resting on the surface of the sea, the study found. When the penguins returned to their nests, their brain waves slowed to a pattern that is typical for sleeping birds, but only for a few seconds. They woke up again, only to fall back asleep. The birds sped through this cycle 600 times in an hour. Humans, too, can experience this sort of microsleep, though typically only after failing to get a good night's rest. It can be dangerous, especially if we are nodding off at the wheel of an automobile. But for chinstrap penguins, microsleep is the norm. Dr. Librel speculated that their sleep patterns reflect the extreme conditions where they doze. Penguin colonies are noisy and crowded, with birds constantly waddling back and forth from the ocean. The habitats are also dangerous. At any moment, a gull-like bird called a brown skua may dive at a nest and eat eggs or chicks. The fact that penguins manage to sleep so much despite all these disturbances suggests to Dr. Librel that the microsleep provides some essential benefit. Scientists have proposed many possible benefits of sleep. Some believe the brain needs it in order to clear away its cellular trash, while others argue that the sleeping brain fine-tunes its cellular connections. But Vladislav Vyazovsky, a neuroscientist at the University of Oxford who was not involved in the research, questioned how much penguins benefit from fleeting bursts of sleep. It's possible, he argued, that we may be thinking about sleep backward. It may be the default setting for the animal brain, and scientists should be trying to explain why animals wake up when they do. You are basically spending your life asleep, and you just wake up when it's needed, Dr. Vyazovsky said. Why sleep? Science asks the iguana. In a laboratory at Indiana State University, a dozen green iguanas sprawl tranquilly in terrariums. They while away the hours basking under their heat lamps, and at night they close both eyes, or sometimes just one. They lead comfortable lives pretty much indistinguishable from any ordinary pet iguana, except for one notable exception. The bundles of brainwave recording wires that trail from their heads. A team of scientists at Indiana State would like to know what happens in the brains of the iguanas when the lights go out. Do they sleep as we do? Do they shut their whole brains down, for example, or can they keep one half awake? These scientists in Terre Haute hope the iguanas will also help shed some light on an even more fundamental question. Why sleep even exists. Sleep has attracted a tremendous amount of attention in science, but we really don't know what sleep is, said Stephen Lima, a biologist at Indiana State. Lima belongs to a small but growing group of scientists who are pushing sleep research deep into the animal kingdom. They suspect that most animal species need to sleep, suggesting that human slumber has an evolutionary history reaching back over 500 million years. Today animals sleep in many different ways. Brown bats for 20 hours a day, for example, and giraffes for less than 2. To understand why people sleep the way they do, scientists need an explanation powerful enough to encompass the millions of other species that sleep as well. One of the reasons we don't understand sleep is that we haven't taken this evolutionary perspective on it, Lima said. Sleep was once considered unique to vertebrates, but in recent years scientists have found that invertebrates like honeybees and crayfish sleep as well. The most extensive work has been carried out on fruit flies. They rest for 10 hours a night, and if you keep them awake longer, they need to sleep more, said Giulio Tononi, a psychiatrist at the University of Wisconsin. The parallels between fruit flies and humans extend even to their neurons. The two species produce, during part of the night, low-frequency electrical activity known as slow-wave sleep. The flies surprised us with how close they were in many ways, Tononi said. Discovering sleep in vertebrates and invertebrates alike has led scientists to conclude that it emerged very early in animal evolution, perhaps 600 million years ago. What we are doing in sleeping is a very old evolutionary phenomenon, Lima said. Scientists have offered a number of ideas about the primordial function of sleep. Tononi believes that it originally evolved as a way to allow neurons to recover from a hard day of learning. When you are awake, you learn all the time, whether you know it or not, he said. Learning strengthens some connections between neurons, known as synapses, and even forms new synapses. These synapses demand a lot of extra energy, though. That means that at the end of the day, you have a brain that costs you more energy, Tononi said. That's where sleep would kick in. He argues that slow waves weaken synapses through the night. If everything gets weaker, you still keep your memories, but overall the strength goes down, he said. The next morning you gain in terms of energy and performance. Tononi and his University of Wisconsin colleague, Chiara Cirelli, present this hypothesis in a paper to be published in the journal Sleep Medicine Reviews. Tononi believes it can be tested, as scientists document sleep in other animal species. It would be a very basic thing that would apply to any brain that can change, he said. It has been almost 600 million years since human ancestors diverged from those of flies. As those ancestors evolved, their sleep evolved as well. Human sleep, for example, features not only slow-wave sleep, but bouts of sleep when the eyes make rapid movements and when we dream. Rapid eye movement, or REM sleep, as it is known, generally comes later in the night after periods of intense slow-wave sleep. Hotheads. Why mammals need REM sleep. Sleeping fur seals toggle between two brain patterns, one while at sea, the other on land. Researchers suggest that REM sleep serves to warm the brain. On a December evening in 1951, Eugene Asrinsky, a physiologist at the University of Chicago, placed electrodes on the scalp of his 8-year-old son, Armand, before putting him to bed. Then the scientist retired to another room to watch a row of pens quiver across a rolling sheet of paper, recording the electrical activity in the boy's facial muscles. Hours later, the pens started to swing wildly. To judge from the chart, it seemed as if Armand were awake, his eyes darting about the room. But when Asrinsky looked in on him, his son was fast asleep. Asrinsky had discovered REM, sleep. Eventually he and other researchers learned that during this state the brain shifts from low frequency to high frequency electrical waves, like those produced in waking hours. When Asrinsky woke his subjects from REM, sleep, they often reported vivid dreams. Almost all mammals experience REM, sleep, but even today researchers debate why it exists. On Thursday, a team of American and Russian researchers reported that fur seals may provide an important clue. While they swim, fur seals switch off REM, sleep entirely. It returns when they come back to land, a pattern never seen before. Jerome M. Siegel, a sleep expert at the University of California, Los